Okay, so just to give you some context for this learning unit, okay, there are three probability distributions that you will need to cover. Okay, now the first one is the binomial distribution. Right? So the first one. The second one is the Poisson distribution. And the third one is the normal distribution. Okay, these are the three distributions you'll cover. Today, I aim to complete these two. And in the next learning unit, the next synchronous session, I'll cover this one. Now, there's a reason why I want to do these two together is because these two deal with a random variable that's discrete. And by now, you should know what a discrete random variable is. A discrete random variable can only take whole numbers or integers. So that means you can have x equal to 0, you can have 1, you can have 2. You can't have something like 1.2. There's no decimals, all right? So these two distributions deal with a random variable that is discrete, okay? In other words, it's counting, okay? You can never have 1.5 things occurring, okay? You can only have 1, 2, 3, etc. This one does deal with continuous random variables. So that means here, your x value can be 1.2, it can even be minus 1.7, etc. Okay, that's the normal distribution. But we are going to cover that in the next session. Okay, so let's begin with the binomial distribution. Now, what is this distribution or binomial distribution all about? The useful property of a binomial distribution is that it enabled you to work out probabilities of events using an equation. And it makes things a lot easier and faster to work out. So let me just take out this Poisson here. I'll tell you what I mean by this. Okay. So for a binomial distribution, you get to use this equation here that I've shown you on the top right. Okay, you don't have to memorize it. It's in your formula sheet. Even in the exam, the formula is going to be given to you. Okay, you're not expected to memorize it. And we'll go to what this equation is all about. All right, but you can only use the equation if the random variable has specific properties that makes it a binomial distribution. All right, so what those properties are basically these two properties that I'm going to list now. If you have an event that can only have, if you have a random variable that can only take two possible outcomes. So in other words, x can be, think for example, it can be a yes or a no. It can be a buy or a sell, okay? So in other words, they are complementary events. So one is the opposite of the other. Think of another one. X is a head or a tail in a coin. Okay, there's no third option. There's only two possible outcomes, and these outcomes are the opposite of each other. Okay, so in other words, there's only two possible outcomes, all right, and these outcomes are complements of each other. So in other words, they're the opposite of each other. All right, so that's the one property. Okay, you first need to identify that X only has two possible outcomes. The second property is that there's a fixed number of trials. So that means, let's just, that first example that I gave you earlier, right? So earlier, just take a few seconds of buy or sell. Okay, so there's only these two possible outcomes. Now, what happens is, what I mean by a certain number of trials is, let's say one trial is a customer coming in. So the first customer comes in, and the next trial is the second customer coming in, next trial is the third customer coming in, and then there's only 4 customers coming in. And each of these customers can only do one of these two possible outcomes. They can either buy or sell, right? Here, you can either buy or sell. And here, this customer as well, buy or sell. Maybe customer is a bad example because, customer can't sell. They can either buy. So let's just say, instead of buy and sell, this customer either buys or doesn't buy the product. Okay, so they buy or they don't buy. It's the same thing. It's so complementary. They buy or they don't buy. So that's what happens here. There's 4 trials, and each of these trials can either have 2 outcomes, which are the opposite of each other. Now, if those 2 properties have been met, then that means this is a binomial distribution. Okay, that means the problem you're dealing with is a binomial distribution. If this still doesn't make any sense to you, let's look at this problem here. That'll put it into context. Right, so I'll read it through to you now. Once a week, a merchandiser replenishes the stocks of a particular product brand in 6 stores. Okay, so I'm just going to highlight this. 6 stores. Okay, all right. For which he is responsible. Experience has shown that there is a 1 in 5 chance. Okay, so that's also going to be a bit important. So let me just highlight that now. There's a 1 in 5 chance that a given store will run out of stock before the merchandiser weekly visit. Right. If you look at the first question, it says which probability distribution is appropriate and why. All right. So in this example, you'll see that there are 6 stores. So in here, the number of trials is 1, 2, 3, 4, 5, and 6. And each of these stores, if you read the question, they can either run out of stock or they will have stock. So those are the 2 possible outcomes. Okay, and they're the opposite of each other. So you either have stock or you don't have stock. So in other cases, in this example, it's not buy and don't buy. It is you have stock or you don't have stock. And they're the opposites of each other. So because this random variable, all right, can only be 2 possible outcomes, which are the opposite of each other, and there's a fixed number of trials, which is actually 6 trials, then you would use a binomial distribution because those 2 properties have been met. All right. I'm checking the chat. Any questions? But assuming so far so good. All right. So now that you know it's a binomial distribution, and we stated why, the reason why is there are 2 possible outcomes which are the opposite of each other, and there's a fixed number of trials. Those 2 reasons, it would justify using a binomial distribution. So that's your question A answered. Because it'll be a binomial distribution for those 2 reasons that I just mentioned. Now let's get down to the calculation question. Right, for question B. Right, question B, what is the probability that on a given weekly round, the merchandiser will find exactly 1 store out of stock? Right, you'll find exactly 1 store out of stock. All right. So in this case, what your X actually represents, it's going to be the number of stores that run out of stock, that don't have stock. Okay, X is the number of stores that don't have stock. And so what question B is asking us to do is determine what is the probability on any given weekly round the merchandiser will find exactly 1 store out of stock. 1 store out of stock. So if X is the number of stores out of stock, what they're asking you to work out is the probability that X is equal to 1. That's what they're asking you to work out. All right. Now we're going to use this formula here. This is where this formula comes in. Now this formula, right? I'll write it a bit bigger so you can see it. It's probability of X equals NCX times P to the X. Right, this is a multiplication. But if you don't like that and it's confusing with X, then we put a dot. It's the same thing. Okay, so that times P to the X into 1 minus P to the N minus X. All right, now, in order to use this formula, we need to know what N is You don't need to know what C is. C is in your calculator. It's just a function. Okay, there's N and there's P. Okay, now N is the number of trials. Well, basically in this problem, it's the number of stores. And there are 6 stores. So your N is 6. Okay, so your N is 6. Okay, that's your N. And then there's another letter in that equation, which is P. Right? Now, P is simply, if you just look at what X is, right? It's the number of stores that don't have stock. So P is that probability of a store not having stock. Now, if you read the question, it tells you that value of P. Experience has shown that there is a 1 in 5 chance that a given store will run out of stock. So P is the probability that any store would be out of stock. So in other words, it's 1 out of 5. So your P is 1 out of 5. I prefer to write it as a decimal, but it's up to you. So it's 0.2. Okay, now we have everything we need to use the formula. So this question, question B, is telling you wherever you see an X, replace it with a 1, because that's what you're trying to work out. So I'm going to use this formula here, and wherever I see X in this equation, I'm going to put a 1. Where I see N, I'm going to put a 6. Where I see P, I'm going to put 0.2. And that becomes 6C1 times 0.2 to the 1 into 1 minus 0.2 to the 6 minus 1. Now, if you enter this in your calculator, and some of you may be wondering, what is this here? This is what we did last week. Okay, this is combinations. In your calculator, if you look at your calculator, right, on the division button, if you look at the division button in your calculator, you'll see above it, it's NCR. That's the same thing as this. So here, you're going to put a 6 in place of the N, and instead of the R, you're going to put a 1 in place of the R. And you're going to work that out, just like how we did last week. Now, if you put all of this into your calculator and work it out, you'll get a value of, tell you now, 0.3932. 0.3932. You can also write it as a percent if you want, but a decimal is fine. So it's 39.32%. Both ways are acceptable. And then 0.32%. All right, I'm just going to pause it for a second. Good. All right. Okay. So I'm going to clear the board here. All right, so that's question B. All right, we'll answer question B. Let's look at question C. Okay. Okay, question C. Now, I'm done question B. Question C is, what is the probability that at most 2 stores will be out of stock? Okay, now at most. Now, it's very important you understand what at most means mathematically. So I'm going to give you 3 options here, and you need to tell me in the chat which is the correct one. And you need to make an attempt here in the chat, okay? Please give this a shot. Doesn't matter if you get it wrong. I need to see that you're trying. Okay, so if you read question C, it says, what is the probability that at most 2 stores will be out of stock? So if I had to write that mathematically, at most 2 stores, would that be this? Would it be option 1? Would it be X greater than equal to 2? Would it be X less than 2? Or would it be option 3, X less than equal to 2? So those are your 3 options. Which of these options, 1, 2, 3, describes question C? And you need to, make an attempt here in the chat, people. Come on, just give it a shot. Is it option 1, 2, or 3? You just need to tell me which one do you choose, 1, 2, or 3. And this is very important that you understand this, because if you get this wrong, then everything else goes wrong when you answer this question. Okay, so this is crucial. What is the probability that at most 2 stores will be out of stock? Would you choose option 1, 2, or 3? So, okay. Thomas, give it a shot. Okay, Vanessa says 3. Thomas says 1. Okay, good. And Kabila, you've got to give it a shot. Is it option 1, 2, or 3? Two. All right. Well, it's quite spread out in front of it for everyone. Okay. It's good that some of you got it wrong, because this is the time to, kind of clarify things and make sure you understand it. The correct option is option 3. This is the correct option. Should be this option here. Okay. And let me explain why. All right. So it's not option 1. It's not option 2. If you say at most 2 stores, okay. If I say something, let me say, if I say I am going to compete in this game, I'm going to play this game. Okay, I'm going to play this game, and the most I can win is 100 Rand. The most I can win is 100 Rand. Okay, so that means I could win 100 Rand, but I cannot win 101 Rand. I can't, because I said at most 100 Rand. I could also win 90 Rand. That's acceptable, because remember I said at most 100 Rand. Anything from 100 and below is acceptable, right? Because I said in this game, I can win at most 100. So in other words, I can win 100, so that means I would include the 100. But anything below it is also acceptable. So that's why it's less than equal to 2. If you think greater than equal to 100, if you think greater than equal to 100, that means you can win more than 100. So in that exact same example I just showed you with this game, and you can win at most 100, it's the same thing with this example. We're saying at most 2 stores. So that means you can have 2. You can have 2 stores. You can have 2 stores. You can have 1 store, and you can also have 0 stores. So 0 is acceptable. You can have a case where no stores run out of stock. So 0 is a possibility. So you can have 2, you can have 1, and you can have 0. And the only one that satisfies that is this option 3. That's why you have to understand what it means mathematically when you say at most 2. All right? So it's option 3. Okay, hope you understand that, but please let me know if you don't, okay? It's very important that you understand this. Okay, so we've agreed now that it's option 3. Let me just check the chat before I move on. All good. Okay, I think everyone understands that now.
Hi, Darren.
Thomas?
How do I answer that question? Is that the option 3? How I will be answering the exact question?
Yeah, that's the start of it. That's the start of your answer. So we still got to do the calculations, but yeah, you have to understand that start, because if you don't get that right, then everything is going to go wrong.
Thank you.
All right, no worries. All right, so now we've established that it's this option here. This is how you would formulate it mathematically, x less than equal to 2. So, good question, Thomas. Yes, so the question is far from finished. We've established that it's going to be this, x less than equal to 2. This is what we need to answer, a probability of this happening. So that means x less than equal to 2, remember, that means you can have the case where x is 0. So that's probability of x equal to 0. You can have that. You can also have the case where x is equal to 1. And you can also have the case where x is equal to 2. Because that's what less than equal to 2 means. Now, if you can work at all 3 of these, which you have to do using this formula here for each of them. like how we did in the example before, then once you do that, you have to add each of them up, and that's your answer. This is an example of a cumulative probability. When you see like an inequality in it, that means you're not just working on one probability, you're working on a number of them, and then you're going to add them up. That's what we're going to do here. You're going to work each of them up, each of them, and then you add them up. Okay, so we do it exactly like how I did before. I'll do it for you, okay? But you can watch this video again and work it out in your calculator. We are going to use this formula here for each of them. For the first case here, you're going to put a 0 in place of x, but your n and your p does not change. The n and p remain the same. The only thing that changes when you're using this equation, when you're solving for x equal to 0, is you're going to replace x with a 0. Okay, now if you do that, you'll get a value of, I'll tell you now, 0.26214. This one is 0.26214. Okay, then you would add it to the next one, which is the probability of x equal to 1. Right? This, I think we did this earlier in the question before for question B, which is 0.3932. And then lastly, the probability of x equals to 2. If you work this out, you get a value of 0.2458. Okay, and you add them all up. That's your final answer. You add these three numbers up, and you get a final answer of 0.9011. Or in other words, 90.11%. I'm just going to write it as a percent. That's your answer. Okay. So that's it's important that you can formulate the question mathematically like this, because that enables you to determine which probabilities you need to answer it, which is this one, you need this one, this one, this one, and then you add them up. All right, so that's question C. Okay. All right. So question D, so that's question C. Question D is quite easy. It says, what is the probability that no stores will be out of stock? So that means no stores out of stock, that means x is 0. So they're just asking you to work out what's the probability of x equals to 0, and we've already done that right here. There's the answer here. You don't need to do it again. All right. Lastly, question E. Okay, so I'm going to ask you this here. Question E says, what is the mean number of stores out of stock each week? Okay. The formula for that, and it's in your formula sheet, you don't need to memorize it. The mean, or a binomial distribution, is simply just your n multiplied by your p. Okay, your mean is just n times p. That's all it is. That's how you get the mean. In other words, it's 6 times 0.2. Okay, because that's your p, that's your n, and if you work that out, I think you get a value of 1.2. And I'll explain why, intuitively, why this is the case, okay? Okay, this is your average. This is the average number of stores you expect to run out of stock. Okay, so how you can think of it is like this, okay? If you, let me just put something new here. All right. If we, and I did this example much earlier in last week's session, if you flip the coin 10,000 times, you flip the coin once, flip the coin twice, all the way to 10,000 times, you would expect the number of heads to be very close to a half of that, which is roughly 5,000. Okay, roughly 5,000. Okay, now, so what, in other words, what you're working at is, you're working at the average number of heads you would get for 10,000 floats. Okay, so let me ask you this instead. If you played a game instead 10,000 times, if you played a game 10,000 times, but your chance of winning, so your probability of winning is 1/4. In other words, 0.25. You got a 25% chance of winning, and it's 1/4. But you played this game 10,000 times. Then the amount of times you would expect to win would be a quarter of this 10,000 times. You would only expect to win a quarter times 10,000 times. All right, because that's the probability of winning. And if you played it 10,000 times, then that's your average. It would be, what is it, 2,500, I think. Let me check. I don't trust my calculation in my head. 2,500. 2,500. Right, so in other words, how you work this out is because this is your P, this whole thing here, and this is your N. The number of trials times the probability of winning. That's how you get your average. So your average number of winning, the average number of times you expect to win is 2,500. It's the exact same principle as what we just did now. Okay, the chance of a store being out of stock is 0.2, and the number of stores is 6. So you multiply your N and your P, and that's the average number of stores you expect to run out of stock. Okay, all right. So that is the binomial distribution. Okay, all right. Let's save this. Now we're going to move on to the Poisson distribution. And the Poisson distribution is different to the binomial. And what makes it so different is that the Poisson distribution also works with a discrete random variable. That is, you're counting the number of times something occurs. So x can occur 0, 1, 2, etc. But it cannot have decimals. You can't have 2.5. You can't have 2.5 customers coming to your store in a month, right? You can only have whole numbers. And you're not just counting the number of occurrences, you're counting it within a specific time interval. So for instance, if you were only interested in the number of occurrences within a day, for instance, if you're just interested in one day, all right, and you're trying to count how many times does this thing occur in one day, then that's a Poisson distribution. If instead of a day, you were looking at a month, if you were just looking at a month, that's still a Poisson distribution because you're counting the number of occurrences that occur within a given time interval, right? And also remember, each occurrence is independent of each other. So that means if I have a customer that comes into the store on day 1, and if I have another customer that comes into the store on day 2, if they are independent of each other, that means this customer does not influence this customer, right? Because they're independent, then that would be a reason to use a Poisson distribution. So remember that for Poisson distribution, you're counting the number of occurrences that happen within a given time interval. Now, if you read this question that we have here on the left, okay, this one I'll read it out. Right, so it says a web-based travel agency uses its website to market its travel products, which are holiday packages. The agency receives on average of 5 web-based inquiries per day. So I'm going to highlight that because we're going to use that. So the average of 5 web-based inquiries per day. And you can see it says per day, all right? So that's a time interval, and we're counting the number of web-based inquiries that happen in a day. Question A says, what is the probability that on any given day, the agency will receive only 3 web-based inquiries? Only 3 web-based inquiries. Now this is a Poisson distribution because you're counting the number of events that occur within a time interval. The events in this case is web-based inquiries, and the time interval is per day. So your first question that you're being asked, all right, is what is the probability that on any given day, as per the time interval given, the agency will receive 3 web-based inquiries. So here what your X is, remember what we said, X is counting the number of occurrences, and in this case, we're counting the number of web-based inquiries. So your X is the number of web-based inquiries per day. Per day. So question A is asking us to work out what is the probability that that x is equal to 3. So now for the Poisson distribution, you are going to use this formula instead, which is probability of x equals e to the minus a, and I'll explain what these symbols are in a second, times a to the x all over x factorial. All right. Now, you'll see this symbol here, e. All right. This symbol e is not a variable. It's actually a value in your calculator. You actually have that button in your calculator, and it is, if you look in your calculator, if you look for the LN button, the LN button, if you look for that, above it, you'll see it has an e to the, with a block. So that's what this thing here is. Okay. The only thing you need to know here for this equation is that your A is the average that's given to you in the question. And if you look at the question, it says your average of 5 web-based inquiries per day. So that's what the A is. Your A is given to you in the question, which is 5. All right. So if we want to work out this probability, all we're going to do is use this equation. Where you see x, you're going to replace it with 3. And wherever you see a, you replace it with 5. So that becomes e to the minus 5 times 5 to the 3 all over 3 factorial. Now, I showed you last week how to work out this 3 factorial. It's in your calculator. If you look at the x to the minus 1 button, above it, you'll see it has an x with an exclamation mark. So that's how you would use this button to find that. And I showed you how to do it last week. So please, you can just watch that as a recap. Otherwise, just use this button here, but you have to use the shift function because you're trying to use the secondary function of that button. All right, so if you enter that in your calculator, all right, you will get a value of, I'll tell you now, you get a value of 0.1404. 0.14. All right. That's how you would do question A. All right. Now question B. Actually, I'm going to, okay, let me do question B. I'm not going to skip it. This is question number A. Okay. Question number B. All right, the question is, what is the probability that on any given day, the traveler agency will receive at most? So here, once again, you're getting tested on expressing at most mathematically. At most, 2 web-based inquiries. All right, so they're asking, what is the probability at x at most, which is less than or equal to 2? That's what you need to work out. So that means you need to work out probability of x equals 0, probability of x equals 1, and probability of x equals 2. And you add them up. Each one of them, you work out like how I showed you in the previous question, right? You need to substitute x. So if you work out this one, you're going to use this equation, right, with a equals to 5. But for here, for this one, you're going to replace x with 0. If you do that using that equation, okay, you'll get a value for this one, which is, okay, I haven't done each of them individually. I'm just going to give you the final answer. Okay, the final answer here, so after you work out each of them and you add them up, your final answer would be 0.1247. 0.1247. Okay, I'd like you to do this as an exercise. So here's the final answer. Okay, you can work out each of them, like how I showed you for question A. All right. So for this one, all you need to do is use this equation, right? Substitute 5 for A, and for X, for this one, substitute 0. Get a value, write it down. Whatever that value is, write it down. Do the same for the next one. Okay, you're now going to replace X with a 1, write on the value. And then the third one, you're going to replace X with a 2, write on the value. When you got these three values, add them up, and it will give you a final answer of 0.1247. Okay? All right. I'm going to check the chat for any questions. Anything anyone's unsure about? Okay. Okay. The last question. All right. Now, the last question is a bit tricky. So I just really need you to follow what I'm trying to do here. And you really need to tell me if you're not understanding this. Okay. Now's your chance to tell me whether you're understanding this concept. So let me get to the question and I'll talk you through the solution. All right. Okay. Let's look at question C, the last one for tonight. I didn't do it intentionally to save the best for the last or the worst for the last, but we have to do it. Okay, question C. It says, what is the probability that the travel agency will receive more than 4 web-based inquiries? Will receive more than 4 web-based inquiries per day. All right, so mathematically, if I had to express question C, which of these options would you select? I'm going to write 3 options there, and you need to tell me in the chat which one would you select. All right. Reading that question in C, would I select option 1, probability X greater than equal to 4? Would I choose option 2, probability X greater than 4? Or would it be option 3, probability X less than 4? Which one do you choose? Option 1, 2, or 3? It's very important you understand this, and you need to give it a try now. Okay, please, I need some engagement here to see if you're following and you're understanding. Question C, which option do you choose, 1, 2, or 3, to express what you're trying to solve for the question? No one's giving it a try. All right, nobody? No takers? Is it option 1, 2, or 3? Everyone says option 3. Everyone says this one, option 3. Okay, no, the option is option 2. Remember, it says more than. More than, the mathematical symbol for more than is this here, greater than. Greater than and more than is the same thing. That's the symbol for more than. Okay, make sure you understand this. More than is the symbol. It's good that you got it wrong now, because now you understand why. This is more than, same thing as greater than, same thing as greater than. This is less than, this is less than. Okay, all right. And then where you have inequalities, that means you include it. It means greater than equal to, and you have the same thing for less than equal to, like that. Okay, but question C doesn't deal with that. So the correct one you should have chosen is option 2, probability of X greater than 4. Okay, make sure you understand that. If you don't understand, please let me know in the chat. I'm happy to explain this again. All right, I'll come back to it. But you really need to ensure that you understand this. So what you're trying to solve for question C is you're trying to solve this. You're trying to work out what is the probability of X greater than 4. Because that's the same thing as more than 4. Let me check the chat. All right, fantastic. All right, now when you say greater than 4, okay, now if I tell you I want a salary greater than 5,000 rands. Okay, that means you can't give me 5,000 rands. I said greater than. I didn't say at least 5,000 rands. That means you must give me 5,010 rand, 5,020. Okay, so that means you don't include 5,000 when I say greater than. In the same way, when I say greater than 4, that means it can be 5, it can be 6, it can be 7, 8, but it cannot be 4. All right, you need to understand it. It doesn't include 4. So in other words, what this question is asking me to work out is this. It's asking me to work out the probability of x equal to 5, because you don't include 4, plus the probability of x equals to 6, plus probability of x equals to 7. Now you may wonder, okay, where does this stop? And that's the unfortunate thing, is that this doesn't stop. This keeps going all the way to infinity, right? Because for Poisson distribution, you can have an unlimited amount of occurrences within a given time. There is no upper limit. There's no stop to how many occurrences you can have. In other words, what you're saying here is there is no limit to how many inquiries you can have on the system, right, for this problem. You're looking at web-based inquiries. So there's an unlimited amount of web-based inquiries that you can have in a day. And now we can't work out every single probability here. This is too long, right? It's not doable. And we need to find some trick to work this out without having to work at all these probabilities. And that's what we're going to use the complement rule. Excuse me. Okay, we're going to use the complement rule here. Okay. So let me try and explain how the complement rule works. And I did this last week, but just as a recap. If I told you your chance of winning is 20%, so your probability of winning is 20%, so 0.2 or 20%, right? Then intuitively, you should know that if your chance of winning is 20%, then your chance of losing is going to be 80%. We're just going to assume that there's no such thing as breaking even, okay? There's no third case. There's only a win or lose, right? We'll just assume that those are only two outcomes. Now, if your chance of winning is 0.2, then your probability of losing is going to be 0.8. Now, if I didn't know this here, if I didn't know this, if I was only given the probability of winning, I can easily work out what the probability of losing is, okay? And that is simply just taking 1 minus the probability of winning. That's how I got the 0.8, because that gives me 1 minus 0.2, right? It gives me the same thing, all right? And that's the complement rule, okay? Now, keep this, what I've just shown you here, in mind. Okay, so what I'm going to rewrite this here and I put on the left. Okay. So remember, it's probability of losing equals 1 minus probability of winning. All right. All right. All I need to know is the opposite of losing, and I can write that. So in the same way, here, if you look at what I've got here now, right? I'm going to write this as its complement on the right-hand side here. Okay. Now, in order to do that, I need to know what is the opposite of x greater than 4. So think of this x greater than 4 as winning. I need to know what is the opposite of x greater than 4. What is its losing equal to, in other words, right? So what is the opposite of x greater than 4? And the opposite of x greater than 4 is this. It's this, x less than equals to 4. That's the opposite of x greater than 4. So in other words, I can write this. I can write probability, so just ignore everything here. I can write probability of x greater than 4 as 1 minus its opposite. That's it. And you may ask me, why am I doing this? Why am I listing its opposite? And the reason I'm doing this is because for the opposite, there is a finite number of occurrences. You don't have to work out an endless amount of probabilities because this, if I just highlight what I'm talking about in green here, just this part here, this is, it's doable. You can work this out. This is simply just probability of x equal to 0 plus probability of x equals 1 plus probability x equals 2 plus probability of x equals 3 plus probability of x equals 4. You include 4 because you can see the sign here, it's less than equal to. So that means here, I only have to work at 1, 2, 3, 4, 5. I can work them out. It stops. It does stop, and it stops at 4. So this part here in green is simply just working out all of these probabilities here in green and adding them up. And if you do that, then what happens is you have this now becoming simply just 1 minus, because there's this 1 here, minus the sum of all of these probabilities. Now, I've done it for you, but you can do it as an exercise. All right, you can work with each of them using this equation, like how you did in the previous questions. Add them up, and the value you get is 0.4405. So it's 1 minus that, and if you work that out to your final answer, after it's 1 minus 0.4405, it gives you the final answer of 0.5595. In other words, 55.95%. That's your final answer. Okay, that's it from my side. Is that clear, everyone? Everyone understand that? Are there any questions? Thanks, Vanessa. Everyone else, if there's any questions, please, now's the time. Yeah, but watch the video again. And like I said, work through the problems before I started working through them. And then play the video as you've worked out the answer compared to what I've got. Okay, it's a good way to consolidate your understanding. The assignment 2, which section is it? That's a good question, Vanessa. It's in your module guide. Let me just check if I can access that. Give me a second. If the rest of you don't have any questions, you're welcome to drop off, or you can say if someone else asks something in the chat. I always understand better after tackling them. That makes sense. Nothing like a bit of stress and it's like forced concentration. But working through problems in general will help you understand the content better. Okay, let me check accessing MOs. Oh, I'm having problems on ARC now. So it's just taking a while for ARC to load. But if anyone has their module outline open, it would be there. Your module outline tells you what that assignment covers. Yeah, sorry, Vanessa. ARC is taking forever to open up here. Okay, but just check your module outline. If you're still not sure, you can just drop me a mail. And then I can access ARC later and I can tell you. All right, everyone. That's it from my side. And thanks for joining. Is it not learning unit 4? So it would definitely be the learning units that you weren't assessed in assignment 1. So in assignment 1, you did learning unit 1, learning unit 2. You weren't tested on learning unit 3. So learning unit 3 would be in assignment 2. Okay, so it's not just unit 4 and 5. Because you weren't assessed on learning unit 3, learning unit 3 should be in assignment 2. And Isabella, does it make sense? Yes, it's likely the 3 could be tested. I'm just going to confirm if that is the case, but Arc's not letting me get in. Okay, but let me just show you, let me just share my screen, and you know how to, because I've given you the links to actually get to your module outline. So share. All right, so if you go to Arc, okay, if you go to Arc and see on the left, on the content, you'll see module information. Okay, so if you click on module information, scroll down, and you'll see a page that says accessing MOs, module outline, and your PAS documents. So you click here, and it shows you how to get your module outline, which you should have already. Okay, you should have downloaded that already and have it with you. But see, as you can see, it's not opening on my side. But if you click here, it shows you exactly how to access your module outline. Once you get your module outline, it'll tell you what learning units assignment 2 covers. It'll be in that module outline. Okay, that would confirm which learning units you need to prepare for assignment 2. All right. Thanks for joining all, and yeah, we will chat soon. All the best.